case, if the powers of P and Q are not equal to 1, that is what we are calling it as non-linear equations. Non-linear equations of first order. So first we'll revise once again what actually the meaning of this is. What is the meaning of first order? Equation consisting of only first order derivatives P and Q. So we don't go with the higher order derivatives, we go with only first order derivatives P and Q, just like Lagrange's here also. But here in this case, we are calling it as non-linear. What is the meaning of non-linear? The powers of P and Q we take other than 1. If it is linear, we are calling it as powers of P and Q as 1. If it is non-linear, we are taking the powers of P and Q as other than 1. Like P square plus Q square is equal to 1. P square plus Q square is equal to Z. Px plus Qy is equal to P square plus Q square. Px plus Qy is equal to 0. So we have some different models where the values of P and Q, I'll take it here, P square x plus Q square is equal to 0. So there are some equations where we have the powers of P and Q are not equal to 1. Though the equation consists of only P and Q's without any higher order derivatives, the powers of P and Q are not equal to 1. So in this case, how we solve these equations? So to solve these equations, generally the method what we follow is we categorize the equations into 4 different types. The examples what I have written on the board also represent 4 different models here. So I will just tell you what actually the 4 different models are. Then we'll go one by one. First model we'll start with. So what is the first model we have here? So you see that in the problem we are having equation consisting of, say the first problem, equation consisting of only P and Q. Though the powers of P and Q are not equal to 1, they are higher powers. Equation consists of only P and Q. It is not having any x, y or z. So this comes under the first model of nonlinear equation. Equation consisting of only P and Q. See the second one. Means I write it as f of pq is equal to 0. First model. See the second model. Equation without x and y. Means equation consisting of p, q and z. So this is the second model, where we have equation consisting of p, q, z is equal to 0. Without x and y. And see the third one. Equation consisting of this one. Last equation. Equation consisting of p, q, x, y without z. But along with that, P and X can be separated with Q and Y. That is the third model. And the fourth model is equation consisting in the standard form Px plus Qy. This is the standard format is equal to f of Pq. That is the fourth case. So now what we do is we go with one by one. So we'll start with the first very model of equation consisting of only P and Q. Non-linear equations where the equation consists of only P and Q. That is the first model. So first model, we are writing it as f of pq is equal to 0. You write down the heading as non-linear PDE of first order. You write down that heading. In that, you write down non-linear PDE can be categorized into 4 types. In that type 1, f of pq is equal to 0. Type 1, f of pq equal to 0. That is equations consisting of only P and Q. That is equations consisting of only P and Q. So for this what we do, before going to the solution part, we just revise one important point in this partial differential equations. Because if you remember, in the case of formation of a PDE, we have seen one rule by forming a PDE by eliminating constants. Do you remember the rule what we have followed? If number of constants is equal to number of independent variables, then order of the differential equation is always equal to 1. Do you remember the rule we have used? The same rule we follow here also in a reverse way. The order of the equation we have taken only 1, means only P and Q are existing in the equation. Number of independent variables. How many number of independent variables will be having in this? 2 independent variables x and y, because we are taking P as rho z by dou x, Q as rho z by dou y in standard format always. Z is a function of x, y. X and y are 2 independent variables. So we have only 2 independent variables over here, and order is equal to 1. In that case, number of constants should be always equal to 2. That is a point you have to remember in your mind while solving this problem. See that we are solving a first order differential equation and number of variables also equal to 2 according to this rule. Since order is equal to 1 and we have number of independent variables equal to 2, constants should be always 2 in the solution. So in all these nonlinear equations, whenever you are writing a solution, you can observe that solution should contain only 2 constants. But while if you get suppose a third constant also, see how we convert the third constant also in terms of first 2 constants. That is a point you have to remember in your mind while solving this problem. So that is the first point you have to remember. Now, what actually this f of pq is? I will explain with a small example. Suppose equation consists of only P and Q. Like suppose if it is given P to the power of half plus Q to the power of half is equal to 1. So this is an example where we have the equation with only P and Q and the powers of P and Q are also not equal to 1. So non-linear partial differential equation of first order of case 1, P f of pq equal to 0. If this is the case, we write the solution directly as z is equal to ax plus by plus c. So this is a standard solution format we write over here. So solution is z is equal to ax plus by plus c. How many constants we have in the solution? We have 3. But we have to write down only 2 constants because we have told you the order. Like number of constants is equal to number of independent variables, order is always equal to 1. So how to convert this? Where f of AB is equal to 0. What did you understand by this term? To write down the value of A and B, I told you if you have 3 constants, you have to convert one constant into any of the 2. So for that, we use this relation. What is the meaning of this? In the equation, we replace P by A, Q by B, and we find out the value of B in terms of A. For example, in this problem, this is a solution part we have written, where what should be written for relation of AB here? A to the power of half plus B to the power of half is equal to 1. So did you understand how I have written this? Where f of AB equal to 0. In the problem directly, we replace P by A and Q by B. From this relation, we write down the value of B. What is B? B power half is equal to 1 minus A to the power of half. Square on both sides. B is equal to 1 minus root A whole square. So therefore, Z is equal to Ax. B is nothing but 1 minus root A whole square into Y plus C. So this will be the complete solution. Now you can observe that in the solution part, we have only A and C, only 2 constants. The third constant, whatever we have B, that is replaced by in terms of A using this relation. So that is the method we follow to solve first model of nonlinear equations. I hope you understood this. I'll repeat once again, see what we have done in this problem. Suppose if the equation consists of only P and Q, then we write the solution directly as z is equal to ax plus by plus c. What is the relation of AB we get here? In the problem directly, we replace P by A and Q by B and we try to find out the value of B in terms of A. That value of B replaced in the solution that gives a general solution of the complete problem given. I hope you understood this. So you take down this problem. We'll practice some problems now for this model. So what we write here also, solution is z is equal to ax plus by plus c. Where what should be the relation of AB we get from the problem here? AB plus A plus B is equal to 0. So I'll take B common from these two. A plus 1 into B plus A is equal to 0. A plus 1 into B is equal to minus A. B is equal to minus A by A plus 1. Therefore, Z is equal to Ax minus A by A plus 1 into Y plus C. There is no rule that always you have to convert B in terms of A. You can also write A in terms of B also and you can write the solution. Only finally what you have to check is in the solution, only 2 constants should exist. Only 2 constants should have in the solution part because we have a relation over there and we have a condition. So if you have finished this, we'll practice one more. Try this one. P square plus q square is equal to 1. Try this one. So here we go with z is equal to ax plus by plus c is the solution. And what is the relation we have for a and b? Where a square plus b square equal to 1. B square is equal to 1 minus a square. B is equal to root over 1 minus a. Strictly speaking, plus or minus, you can write b is equal to root over 1 minus a. So therefore, z is equal to ax plus root over 1 minus a square y plus c. So that will be the solution. You just check your answer. So now we go with the second model. What is the second model I told you? Equation consisting of p, q and z. So f of p, q, z is equal to 0. That means equation without x and y. So what we do, as a trial solution, we assume the solution is of the form of z, which is a function of u is equal to x plus ay. So what we are assuming? We are assuming the solution as z. How the z is? Z is a function of u is equal to x plus a. So what we do here, we just find out what actually the values of those at p and q what we have taken. What is the value of p actually we have taken? P is dou z by dou x. But see here that p is first, we have taken the function of z. So first z is a function of u and u are the functions of x and y. So this is the order we have to follow while calculating the derivative. Chain rule we follow. So what we do, dou z by dou x can be calculated as dz by du into dou u by dou x. Did you understand why I have written this as total derivative and this as partial derivative? Because z is a function of only one variable u, whereas u is a function of two variables x and y, independent variables. That's why this derivative I have written as total because only one variable here. Whereas this variable, this derivative I have written partial because y to be taken as constant here. Because two variables are existing here, we are doing with respect to x. We have to consider y as constant. I have just applied a chain rule over here. So P is equal to dz by du into what is the value of dou u by dou x? This is the value of u you have taken. So dou u by dou x, x derivative is 1, y constant derivative becomes 0. So whenever you come across the value of P in the problem, we replace it by dz by du for a second model. Equation consisting of P, Q and Z. So what we do in that case, as a trial solution, we assume the solution as Z. How the z we have taken? Z is a function of u is equal to x plus ay. So in that case, we have found what actually the value of p is. P is dou z by dou x. Generally, we have used this chain rule. Dz by du into dou u by dou x. Dou u by dou x value from this relation we have 1. So the value of p is dz by du. Similarly, if you take q, what is the value of q we have taken originally? Dou z by dou y. How we again take the chain rule dz by du into dou u by dou y. So what is the value of dou u by dou y from this problem? Partial derivative of u with respect to y, keeping x as constant. So x is constant, derivative is 0. So what is the derivative of y here? It is a. So the q is equal to a times dz by du. So whenever you come across the value of q in the problem, we replace it by a dz by du. Remember, if this type of problem is given in the exam, first you have to show all these and then only you have to substitute. You cannot go directly with p dz by du. In this class now, while doing the remaining problems, you can directly take pq values in this class and you can solve it. But if this type of problem is given in the exam, first you have to show how actually P is becoming dz by du, how Q is becoming a dz by du, then only you proceed with the problem. So if you substitute all these in this, how the solution will become now? This will become, the equation becomes now, equation becomes P is dz by du, Q is a dz by du, and this is Z. You can observe here that A is constant. You can observe here that equation consists of two variables Z and U. and total derivatives. So it can be converted into first order, first degree, ordinary differential equations. Whichever method is applicable for that equation, like variable separable, homogeneous, exact, you can use that method, you can solve this equation. What we have done in this, we have reduced a partial differential equation into a first order, first degree, ordinary differential equation. From this, we proceed with finding out the solution part. I will explain this model with an example. If you have finished writing this, you write down after writing this, you write it as it is converted into first order, first degree order differential equation and can be solved. Okay, suppose if you are given a problem like P into 1 plus Q, P into 1 plus Q is equal to QZ. So you can observe here that this is a non-linear equation because we have a term of P into Q and QZ. And also, equation consists of P, Q, and Z in this format. So what we do as a trial solution, let Z be a solution which is a function of U is equal to X plus CY. So wherever you come across P, replace it by dz by du. Wherever you come across Q, replace it by A dz by du. This is what I am telling you. In this class practice session, you can directly take this. But if this type of problem is given in the exam, what we have done before, how we have reduced this P to dz by du, how we have reduced this Q to A dz by du, you have to show this clearly and then only you have to proceed with the problem. It can be, while doing the practice session, you can directly write the value. But in the exam, don't forget to show this value also. So to substitute, what will be the value? Dz by du into 1 plus A dz by du is equal to Q. Q is again A dz by du into Z. So we have a dz by du term common from both. I will remove. I will eliminate it. So this will become 1 plus A dz by du is equal to Az. So A dz by du is equal to Az minus 1. Now I'll apply the variable separable form. This is a z function. I'll bring it to left hand side. A by Az minus 1 dz is equal to du. You can observe that this is a variable separable form. And this is also in the form of f dash by f. So how we write this? Log Az minus 1 is equal to u plus a constant c. So this will be the complete solution. In this also you can observe that we have only two constants in the solution, a and c. So I'll repeat this procedure once again, just see. So if the equation consists of, non-linear equation consists of P, Q and Z, only P, Q and Z without X, Y. As a trial solution, we assume the solution to be of the form Z, which is a function of U is equal to X plus A, right? So I have told you how we got these values of P and Q. The value of P, we get it in the form of dz by du by using chain rule, and Q is A dz by du. We replace these values of P and Q in the given problem. P is dz by du into 1 plus Q is A dz by du is equal to Q is A dz by du into Z. Dz by du is common, so remaining terms I am writing here. 1 plus A dz by du is equal to Az. I have applied the variable separable form by writing A by Az minus 1 dz is equal to du. So since this is in the form of variable separable form, we have integrated on both sides. So this is in the form of f dash by f. So this is log Az minus 1 is equal to integral of du is u, integration constant is c. So this is a complete solution for this equation. Even in this also you can observe that the solution consists of two constants a and c. So just take down, we'll practice some problems related to this model also. So in this also we take z as a function of u is equal to x plus ay. P is a dz by du, q is a, p is dz by du, a q is a dz by du. If you replace this becomes dz by du whole square, and q is a dz by du whole square. So z is equal to 1 plus a square into dz by du whole square. So dz by du whole square is equal to z by 1 plus a square. So dz by du is equal to root z by root over 1 plus a square. Use variable separable form. Write it as 1 plus a square dz by root z is equal to du. So root over 1 plus a square, integral of root z by z is 2 root z is equal to u plus c. So 2 root 1 plus a square into root z is equal to u is x plus ay plus c. That is the solution. So you try this one. The next one. Z square is equal to 1 plus p square plus q square. Try this one. So in this also we have used as a try solution. Z as a function of u is equal to x plus ay. So wherever you come across p, we replace it by dz by du, q by a dz by du. So if you replace it, this will become dz by du whole square, and this is a dz by du whole square. So I'll bring this z square minus 1 to the left hand side, 1 plus a square dz by du whole square. So what will be dz by du whole square value? Z square minus 1 by 1 plus a square. So dz by du correspondingly will become root over z square minus 1 by root over 1 plus a square. Just like the last problem, we go with variable separable. 1 by root over z square minus 1 dz. I'll leave this constant root over 1 plus a square here only with du. Integrate on both sides. This value is z square minus 1. This value is cos hz is equal to u by root over 1 plus a square plus constant c. So cos is equal to x plus ay by root over 1 plus a square plus c. Cos h inverse z kada idi 1 dz by 4 z square minus 1 is cos h inverse z. So you can leave the solution like this. So what will be the solution? Cos h inverse z is equal to x plus ay by root over 1 plus a square plus c. Now I'll explain to you the case 3, model 3. So in this what actually we have in case 3, we will be having equation consisting of p, q, x and z. P, q, x and y means equation without z. Along with that, the functions of p, q, p and x can be separated with the functions of q and y. If the equation is of this model, like equation consisting of p, q, x, y, along with that, if p and x separated with q and y. In such a case, how we write down the solution for this? We know if z is a function of xy, we know how to write the total derivative of dz. Remember the chain rule? Dou z by dou u into dou u by dou x. I'll write down the total derivative dx form. Dou z by dou x dx plus dou z by dou y dy. This is the total derivative we have written. And we know dou z by dou x is p and the value of dou z by dou y is q. We use this concept to solve this equation here. What we do, if suppose p and x got separated with q and y in the problem, we equate each to a constant. It may be constant k or it may be constant c. So what we do, from the first relation, f of p and x is equal to 0, we try to find out the value of p as in terms of x. From this relation q of yq is equal to c, not 0, sorry, c. We try to find out the value of q in terms of y. So from this relation, we try to find p in terms of x. From this relation, we try to find q in terms of y. These p and q values we substitute here. So function of x dx, function of y dy. This will become now a pure relation or pure differential. Integrating, we get directly the solution part. I'll explain with this with an example, it will be more clear. So I hope you have written this. I am erasing this part. Suppose if a problem is given like p square minus q square is equal to x minus y. See, in this problem, we have only PQXY without Z. Along with it, see whether we can separate PQXY also. P square, I'll bring this x to the left hand side, bring this q square to the right hand side, q square minus y. So we have separated P and x on one side, q and y on other side, equate each term to a constant. So k or c, whatever may be, c and better to be more convenient. So p square minus x is equal to c, or p square is equal to x plus c, or p is equal to root over x plus c. So this we got as p. Q square minus y is equal to c, q square is equal to y plus c, q is equal to root over y plus c. Strictly speaking, plus or minus, I have taken only plus c, plus root over. So what is the relation we have? We have dz is equal to dou z by dou x dx plus dou z by dou y dy. This is p dx plus q dy. Whatever we have calculated as p and q, we substitute here. Root over x plus c dx, root over y plus c dy. So this is completely a pure relation. Now we'll integrate. On integrating, what we get? On integrating, we get z is equal to x plus c to the power of half plus 1, 3 by 2 by 3 by 2 plus y plus c to the power of half plus 1, 3 by 2 by 3 by 2 plus some constant k. So how the solution now reduces to z is equal to 2 by 3 x plus c to the power of 3 by 2, 2 by 3 y plus c to the power of 3 by 2 plus some constant k. Even in this is a solution. Even in this also you can observe that we have two constants c and k in the solution part. Suppose if you are given root p plus root q is equal to x plus y. So even in this problem also we have only pqxy without z. So and also we can separate p and x on one side. How can we separate it? Root p, bring this x to the left hand side as minus x is equal to minus root q plus y. Equate each term to a constant k. Root p minus x is equal to k, or root p is equal to x plus k, or p is equal to x plus k whole square. Similarly, minus root q plus y is equal to k, or root q is equal to k minus y. This is the value we get. Root q is equal to y minus k. Q is equal to y minus k whole square. We got the values of p and q. We have dz is equal to p dx plus q dy. And the value of p we have calculated is x plus k whole square. And the value of q is y minus k whole square. So integrate on both sides. X plus k whole cube by 3, y minus k whole cube by 3, plus some constant c. So this will be the solution part. So we have two or three problems which are given in the textbook. I think you can practice those problems also of this model. We'll go with now the last case, fourth type. The fourth type, actually, the equation will be in a standard format. How the format will be? Z is equal to Px plus Qy plus f of Pq. This should be the standard format for the equation. How the equation should be? Left hand side should be Z is equal to. First term should be Px. Second term should be Qy. Third term should be, or third from third, the term should be of functions of P and Q. Only P and Q. Suppose if you are given like Z is equal to Px plus Qy plus P square plus Q. See in this problem, the equation is in the standard form of Z is equal to Px plus Qy plus f of Pq. The solution for this equation is directly, there is no need to solve anything. simply we replace the value of p by a and q by b in the equation. So solution is ax plus by plus f of ab. So how the solution will be now? This will become now ax plus by plus a square plus b square. That will be the solution. There is no need to write down any or solve anything. Just replace the value of p by a and q by b in the solution. That gives directly the equation. So this comes as case 4. We can write another one. Z is equal to px plus qy plus root pq. In this also we can write solution is z is equal to ax plus by plus root ab. So these four are the non-linear equations we have in first order partial differential equations. So I'll just revise once again all the four cases and what are the methods we have solved, and we'll wind up the class today. Okay? I hope you finished these two problems. Okay. What are the four cases we have here? The first case is f of pq is equal to 0. Equation consisting of only p and q. So in this case, what is the solution we have written? Solution we have written is z is equal to ax plus by plus c, and we have a relation for a and b as f of ab is equal to 0. So if the equation consists of only p and q, write the solution as z is equal to ax plus by plus c, and the relation between a and b we get from the problem directly by replacing p by a and q by b in the equation. The second one is equation consisting of p q z is equal to 0. So as a trial solution, we assume z, which is a function of u is equal to x plus ay. So wherever you come across p, we replace it by dz by du. Wherever you come across q, we replace it by a dz by du. So the equation becomes now dz by d function of dz by du, a dz by du along with z. You can observe that the equation reduces to a first order, first degree differential equations, and then we can solve it by using any method which is applicable to the problem. The third one is equation consisting of t, q, x and y without z. Along with that, if function of px can be separated with function of qy. We equate each term to a constant c. We try to find out the value of 1 and f1. We can write out the value of p is a function of xy as p as a function of x and q as a function of y. So that we replace in the relation dz is equal to p dx plus q dy. So this will be converted into a pure total differential form, and to get the solution we simply integrate it. The fourth type of equation is if the equation is in the form of z is equal to px plus qy plus f of pq. Then the solution is directly simply equal to z is equal to ax plus by plus f of ab. So these are the four methods we have used or we have taken to solve a non-linear first order partial differential equation. So if a problem is given in the exam, you say just see into which category it is categorized according to this rule, and you apply the corresponding method to solve that problem. So these are the four cases we have seen in non-linear partial differential equations of first order.